Okay, this is the 6-1 to 6-3 review. Calculators are not allowed, and it's number 5. And I'm going to do each of these two different ways. I'm going to do the washer method and the cylindrical shell method. And on the exam, you can do it either way. But hopefully, as we go through this, you'll see that the cylindrical shell method is actually more it's just easier to do. It doesn't have as much complicated arithmetic. So if we look at part A here, it says we want the graph that is bounded by the y-axis. The curve y equals 3 times a root, so that's just going to be a root shape. We don't really need to care about the proportionality of it. And this line y equals 15. So we do need to know where those intersect. So this is our first step of the process. We figure out what our region is and what we're rotating around. So here I've got a 0, 0. Here I've got a 0, 15. And then out here I need to know when 15 equals this. So when does 15 equal 3 root 5x? Well, that's when 5 equals the square root of 5x. Or when 25 equals 5x and x equals 5. So we've got another point here, 5, 15. Alright, so now if I'm going to do washers and discs, that means I need to cut perpendicular to what I'm rotating around. So we'll begin with this strip, and we will label with y's. So on this one we have a y comma, or 0 comma y, and over here we're on the curve and we need to have the x isolated. So if I isolate x on this, I will get y over 3, and then I have to square it, and then I have to divide by 5. So that'll give me my x. If I multiply that out, I get a y squared over a 45 equals my x. So this will be a y squared over 45 comma y. Alright, so now when I create my representative slice now, we can see that this is going to wrap around and become a disc. So that inner radius is going to be 0, and the thickness is going to be dy. The radius will be the length of that strip, which is a y squared over 45. So when I set up my integral now, I'm going to have the volume is the integral with the pi times that big radius squared dy, and the y's are going to go down to 0 and up to 15. And that radius, since I don't have a big radius, or excuse me, a small radius, I'll just have this. So if we think about the constants that I can pull out in front, I'm going to have a pi and a 45 squared. And inside, I'm going to have a y to the 4th. So the antiderivative of that will give me pi over 45 squared times a y to the 5th over 5, and that's evaluated from 0 to 15. So without a calculator, that means we've got to do some factoring to help us simplify this. If I plug in 15, I'm going to have a 15 to the 5th, and if I look at the bottom, that's actually a 15 times a 3 that's been squared. So I have a 15 times a 3 times a 15 times a 3. And then here I will have 5 of those 15s over a 5 minus a 0. So I can start to cancel here. I have a 15 cancels with a 15, another 15 cancels with a 15. I've got a 15 on the bottom here, that cancels, and then I have a 3 that can cancel here and give me a 5. So I end up with a 5 times a 15, which gives me a 75 pi. So that was doing it with the washer method. So if I want to do the cylindrical shell method, which hopefully you will see tends to be a little simpler, I'm going to pull this down here, and we'll have the exact same region drawn. Let me just get this on here real fast. Same region. We're still rotating about the x or the y-axis, excuse me. except this time, instead of rotating around, or instead of slicing perpendicular, we're going to slice parallel. So if we slice parallel, that means we need to have x's the same, and we need to have the y's isolated on the curve. So up here we can see that the the y value is going to be 15. And on this one, remember that that curve was y equals 3 times the square root of 5x. So this one's going to be 3 times the square root of that 5x. So now if I create my sample region, it's going to be that strip rotated around the y-axis. So the thickness of that strip is going to be a dx this time, and the height of that strip is going to be a 15 minus a 3 root 5x, and the distance between the strip and the axis of rotation is going to be the distance between this point and this point, and we can see it's an x minus a 0. So my radius is going to be x. So if I fill this out now on my integral, set it up, I'll have volume equals a 2 pi times the radius, which is x, times the height, which is 15 minus 3 root 5x with respect to x, and I'm going to accumulate from, looks like 0 to 5. So if I multiply this out, I'll have volume equals 2 pi integral of 15x minus 3 root 5 times, this is an x to the 1/2 times another x gives me an x to the 3/2 from 0 to 5. So antiderivative now will be 15x squared over 2 minus, I can move through that 3 root 5. I'll add 1 to this power, so that x to the 5/2 divided by 5/2, and that's evaluated from 0 to 5. So if I plug in my 5, I will have a 15 times a 5 times a 5 over a 2 minus a 3 root 5 times a 5 to the 5/2, and I'm going to flip this and get a 2/5. And then when I subtract, what comes out when I plug in 0, that's just a 0. So to this point, need to simplify it. And to get a common denominator, looks like I need a 5 on this one and a 2 on this one. So I got another 2 and another 5. So let's look at what we have here. We have a 5 times a 5 times a 5 times a 15. And then we're going to subtract a 3 times a 2 times a 2 times a 5 to the 1/2 times a 5 to the 5/2. That's going to add those exponents. I'll get a 5 cubed. And this is all divided by a 5 times a 2. So let's figure out what that is. Looks like I got 3 5s here and 3 5s here. I've got 15 of them in the front, and I've got 12 of them in the back, which gives me 2 pi over, I've got 3 of those 5 by 5s by 5s over a 5 times 2. So the 2's will cancel, one of the 5's will cancel. I get a 3 times a 25 gives me that 75 pi.